Okay, so get ready because today we're going deep on something kind of weird.
Yeah, this one's out there.
Yeah, we're talking about a global problem that you probably only think about when you got to go.
Right.
2.6 billion people on this planet don't have access to proper sanitation.
Wow.
That's a huge GE number, and it causes some major health and environmental issues.
It really does. It's a crisis that we don't talk about enough, but the impact is huge.
Totally. And what if I told you one of the best solutions might be insect larvae?
I know, right? Sounds crazy. But hear me out. We're going to dig into some amazing research about Black Soldier Fly Larvae, BSFL for short, and how they can break down human waste.
BSFL. All right. I'm intrigued.
And this isn't some amateur experiment. This is legit science.
So paint me a picture. We've got these researchers in a lab feeding actual human waste to these larvae.
It's exactly what it sounds like.
And their goal is to see if BSFL could actually be a solution for waste management on a big scale.
Exactly. And that's where it gets really interesting. They wanted to know how different things, like how much waste they got at once or how many larvae were used, how those things affected the process.
Okay, makes sense. You got to start somewhere, right?
Right. And figuring out these details is super important if we want to take this from the lab to the real world.
Okay, so speaking of details, one thing that really surprised me was that the larvae actually grew bigger when they were given a ton of waste all at once.
Yeah, it seems strange.
Like, talk about picking out.
Yeah, but there's a cool biological reason for it.
Okay, I'm listening.
So human waste, as gross as we think it is, can actually be really different in terms of nutrition.
Hold on, are you saying there's such a thing as nutritious poop?
No, not really. It's more about balance. When the larvae got a huge amount of food at once, it kind of messed up their nutritional balance.
I see.
Like if all you ate was junk food all day, you might be full, but you wouldn't be healthy.
Yeah, that makes sense.
These larvae are super adaptable, though. So they basically gorged themselves to get the nutrients they needed from this huge feast.
So they're like the ultimate survivors making the most of whatever, or should I say, wherever they find themselves.
Exactly.
But that makes me wonder, if they're growing bigger on a less balanced diet, does that mean they're not breaking down the waste as well?
That's the million-dollar question, right? And this is where the research gets really interesting.
Okay, so let's hear it. What do they find?
Well, even with that single massive feeding, the BSFL were really good at reducing the waste.
Okay.
Now, the exact numbers were different depending on how many larvae they used and how often they were fed. But some groups got rid of almost 50% of the waste.
50%? Seriously?
Yeah,
That's as good as or even better than some composting methods.
it is.
Wow. So we're not talking about some small improvement. This could be huge.
Exactly. And it gets even cooler when you look at what happens to the waste that the larvae actually eat. That's where we get into bioconversion.
Bioconversion. Okay, break that down for me.
Basically, these larvae are like little recycling machines. They take that waste and turn it into valuable biomass, their own bodies.
Wait, are you saying we should start eating these larvae? Because I think I have to draw the line somewhere.
No, not at all, at least not today. But the larvae are packed with protein and fat, which makes them perfect for animal feed.
Okay, that makes a lot more sense.
So we're talking about turning human waste into a sustainable food source for livestock.
Now that's what I call closing the loop, going from a major health hazard to a valuable resource. But I'm guessing it's not as simple as just releasing swarms of larvae into every sanitation system, right?
You're right. This study was done in a controlled lab. To really use BSFL for waste management, we need to create the perfect environment for them to thrive on a much bigger, less predictable scale.
Right, because the real world is a lot messier than a lab.
Exactly. And of course, there are some potential downsides we have to consider too.
Like, what happens if these larvae escape? Could they become an invasive species? And what about toxins building up in their systems? We need to understand these things before we go all in on this technology.
You're right on. We don't want to solve one problem and create a bunch of new ones.
Exactly. So with those bigger questions in mind, let's dive deeper into what this study actually found.
Let's do it.
So we know these larvae can really break down waste, but this study went deeper than just proving that BSFL can eat our waste. They looked at efficiency too.
Exactly. And one of the key things they measured was the feed conversion ratio.
Okay, feed conversion ratio. Now, in English, what does that actually mean?
Well, it's a way to see how well an organism turns its food into body mass. It's like how a cow needs to eat a ton of grass to gain just 1 pound. That means cows have a pretty high feed conversion ratio. But BSFL are super efficient. They can eat way less waste and still gain a lot of weight.
So basically, a lower feed conversion ratio is good news if we want to get rid of waste and create something useful.
Exactly. And in this study, the best feed conversion ratio happened when they fed the larva 100 milligrams of waste per larva each day. They called this the optimal feeding ratio.
Interesting. So there's a sweet spot where we can get rid of the most waste and grow the most larvae. But what about the stuff the larvae don't eat? Is there anything left over?
That's a great question. Even with the best eaters, there's always going to be some leftovers. But that doesn't mean it's useless. It can be composted even more, or even used to help soil. Remember, it's all connected.
Right. It's about going from waste to resource and back again. You mentioned the study also looked at different feeding schedules. Did they see any differences in how the larvae responded to, say, one big meal versus more frequent smaller meals?
They did. And this goes back to that adaptability we were talking about. The larvae that were fed less often, meaning they got a big amount of food all at once, they actually got bigger. But it also took them longer to reach the prepupal stage.
Just to be clear, prepupal stage, that's when they're ready to turn into flies, right?
Exactly. It's pretty amazing. They go from these tiny wiggly larvae to plump, nutrient-rich prepupa, and then finally adult black soldier flies.
Okay, so the larvae on the less frequent schedule caught up in size. Eventually, they just took their time. What's the takeaway there?
It just shows how adaptable these creatures are. They can handle it even when food is hard to come by, which is really important when we're thinking about something like human waste, which isn't exactly the most consistent food source.
That's a good point. This is all really promising. But I know some people listening are probably thinking, okay, this is cool and all, but how does this affect me? So let's bring it back to the bigger picture. Why should we care about a bunch of larvae munching on? Well,
It's a fair question. It might seem like a small thing, but this is about finding ways to deal with global problems that affect all of us. Think about how much energy and resources go into our current waste management systems. Landfills, treatment plants. It takes a lot, and it can really hurt the environment.
and that's not even mentioning the health risks that come with bad sanitation, especially in developing countries.
Exactly. So if we can manage waste better in a way that's good for the planet and uses resources, well, everyone wins.
It feels like we're close to something big here. But like with anything new, there are always challenges. What are some of the hurdles we still need to overcome?
Well, first, there's the whole ick factor. Let's be real. Not everyone's cool with bugs eating their waste, even if it's happening out of sight. We got to find ways to get over that and help people see how amazing this technology could be.
We've talked about how BSFL could really change how we deal with waste.
Definitely.
But what does that actually look like in real life? Are we talking like high-tech toilets in every home or what?
It's bigger than just toilets. Think about all the food waste from restaurants, grocery stores, farms. Even BSFL could process all that right there, cut down on landfills, maybe even make those businesses some money.
Now that's closing the loop, turning trash into treasure.
Exactly.
We've mentioned developing countries. What kind of impact could this have?
Huge potential. In lots of developing countries, good sanitation is hard to come by. It causes real health problems. BSFL could be a way to manage waste locally, even without a lot of fancy technology.
So instead of relying on those big, expensive treatment plants that are hard to get to,
Right.
communities could use BSFL to handle their own waste right there.
Yeah.
Help stop diseases, improve sanitation overall.
Exactly. And besides the health benefits, think about the economic possibilities. We talked about communities selling the larvae as animal feed or using the leftovers as fertilizer, creating a circular economy, even in places without a lot of resources.
Love it. One person's trash is another's treasure, or in this case, a whole community's opportunity. But we got to talk about the elephant in the room, or I guess the larvae in the compost bin.
I hear you. There's no getting around the whole ick factor of using insects to deal with waste.
For sure. So how do we get over that initial disgust? How do we convince people that these little guys, as weird as it sounds, could be the answer to a cleaner, greener future?
Education is key. The more people know about how efficient BSFL are, how good they are for the environment, the less scary they become. Maybe even appealing.
Appealing. I like it.
Yeah.
We need a marketing campaign, BSFL, not as creepy as they sound. But really, besides education, what else needs to happen to make this a reality?
More research for sure. This study looked at fresh human waste, but there's so much more to learn. How do BSFL handle different kinds of waste? What's the best way to scale up production? We got to find those answers.
And like we said, figuring out the rules and regulations is huge. We need clear guidelines, safety protocols to make sure this is all done responsibly.
Absolutely. And that means dealing with any risks stopping larvae from escaping, making sure they don't become invasive or soak up harmful stuff. Transparency and responsibility are key.
It's about finding that balance, right? Using this amazing technology, but being careful thinking about any possible downsides.
Exactly. It's a marathon, not a sprint. We need a smart, multifaceted approach. But I really believe that with more research, public education, and responsible implementation, BSFL can change how we think about waste management forever.
So next time you're, making a deposit, take a second to think about nature's little recyclers hard at work. Those larvae, as strange as they may seem, could be leading the way to a cleaner, healthier planet. Thanks for joining us for this deep dive into the surprisingly fascinating world of BSFL and waste management.